Okay, in this video, I'd like to look at this composition of functions discussion again. We're going to get to quadratic here. So let's start with this. Let's start with the function f of x equals 3. Okay, so what that means is no matter what value I place in here, it just equals 3. So you're looking at this x right here and thinking, where is the x coming from? Well, the x is coming from this x-axis. All right, let's look here and let's label this 1, 2, 3, 4, so on, and then -1, 2, -2, -3, -4. And we want to know what is the y value when x is one of these values. And you could put in any number you want. It doesn't even have to be whole numbers, but these are easiest to work with. So for example, you plug in a 1 right here, f of 1 just equals 3. So at all points where you're plugging in x's, the y value will be 3. So you can draw a line at 3 on the y-axis, which represents every potential x value that you would put into that function. Okay, it's pretty easy to draw that line. Okay, well now let's look at one that actually is a little bit more complicated. How about f of x equals 2x? Okay, well now when we plug in an x value, we have to multiply it by 2. So if I plug in f of 1, then that's 2 times 1. Well, 2 times 1 is 2. So at x equals 1, f of x equals 2. So on the y-axis, this is the y-axis here, f of 1 is 2. Put a dot there. How about f of 4? Okay, when x is 4, f of x, or y, is 2 times 4, which is 8. That goes beyond even the limits of this particular graph. 4, 5, 6, we'd have to extend the graph up. 7, 8. Okay, so there's the 8 line right there. Let me just draw this. So at f of 4, the y value is 8. That point would be about right there. Okay, so this is f of 4 right there for this equation, f of x equals 2x. All right, so if we want to connect those two dots, here's what that line looks like. Right, so now you've got a line passing through those 2 points. There's your line for f of x equals 2x. Well, now let's look at f of x equals, I don't know, let's do x squared. Okay, so now when I plug in a value for x, I have to square it. So 1 going in here for x means 1 times 1, that's 1. So here's a point on that line. How about f of 2? Okay, plug in a 2 for the x. 2 times 2, 2 squared, is 4. So I go up here where x is 2, and I go all the way up to 4 and put a dot right there. Okay, f of 0. 0 squared is 0. F of -1. -1 times -1 is +1. f of negative 2. Negative 2 times negative 2 is positive 4. So my line here is actually this curve. Okay, so this is what that one looks like. Just stick with me on this. Let me draw this in. This is a quadratic curve where the other two lines were linear curves. Okay, so that's kind of what that line looks like. So now we've got these three lines all graphed, okay? And so the question is, what if we added them all together? Okay, and we had f of x plus f of x plus f of x. Well, you'd have 3 plus 2x plus x squared. Okay, so f of x now equals the composition of all three of these functions. But this isn't the form they want us to write it in. They want us to write it in this other form where the x squared comes first, then the 2x, and then the 3. So let's just rewrite that using this standard form, which puts the highest exponent term up front, and then the second highest term, and then the term with no x at all, 3. So what does this graph look like? Well, what you want to do, and we'll do this in red, is you want to go through and find all of the different values that these lines have at given x values. So let's look at f of 1. At f of 1, I have one line here with a y value of 1. I have another line here with a y value of 2. And then here's a line right here with a y value of 3. So at f of 1, I will place my dot at the sum of these three y values. So 1 plus 2 is 3. 3 plus 3 is 6. 4, 5, 6. So here is where my line will pass through that point right there, 1, 6 at f of 1. All right. How about f of negative 1? Well, we don't have to plug numbers in here. We can just look and see here at negative 1, these are my three cross points. Okay, what are those numbers? Well, this is negative 2 plus 1 plus 3. Negative 2 plus 1 is negative 1. Negative 1 plus 3 is positive 2. So at x equals negative 1, my value is at 2. How about 0? Okay, if I have it at 0, I've got two of my lines passing through the origin and one line passing through at 3. So at 0, my line is at 3. Okay, so now I have these 3 points here, here, and here. Well, let's keep going. Let's look at negative 2. Okay, so at negative 2, where are my lines at? Here's one cross point right here. Here's one cross point here, and here's one here. So what is this? Negative 1, negative 2, negative 3, negative 4. This is negative 4 plus 3, that's negative 1, plus 4 is 3. So here's my point at, I'm going to make this big, f of negative 2. So now I've got these three big points here, all right? Let's try another one. How about f of negative 3? Well, it's kind of going off. Now we're getting to where this line is kind of going off the page. a little bit, it would be, that would be a casual, I would be suffering a casualty of drawing incorrectly to try to estimate that point. Let's just see, it kind of looks like it would be, this line looks like it would be at y equals 7 or something. Let me evaluate that. That was x squared. So what we're evaluating at -3. Let's -3 times 3 times -3 would be +9. So actually this needs to be going up more narrowly. The way I've drawn it is too fat. It needs to be going up more narrowly. More like this. Like that, okay? And so at f of -3, let me just draw some more lines in here. This was 3, 4, 5, 6, 7, 8, 9, okay? There. So at -3, my quadratic graph is going to be crossing through that point right there. So here's a point, f of -3. Here's a point, and then down here, here's a point. What is that supposed to be? Be 2x down 2 over 1. It should be right there, okay? So let's add up those. We have -1, -2, -3, -4, -5, -6, plus 3. That's -3. Okay, and then -3 plus 9 is +6. So my next value is at 3, 4, 5, 6. Okay, so that's right here. Okay, so my new line that I'm going to draw in blue here looks like it has the bottom of the graph is here at 2. Okay, maybe not. At 0, it's 3. Okay, here it kind of looks like this. This is what I think. You know, I could be wrong. Something like that. Maybe. So let's check. Let's check using Desmos. See if we were right. Let me go to Desmos real quick and get that set up for us to look at. Let me share my screen with you so you can see just what I'm looking at here. Okay, so if I plug in y equals 3, there's that line. The next one, y equals 2x, there's that line. The next one, y equals x squared, there's that line. Okay, those are all the lines we already drew. Now let's type in y equals x squared plus 2x plus 3. Okay, now we thought on our picture, looks pretty good, right? We thought on our picture that at f of -1, when x is -1, we thought y was 2. Let's see if we're right. There it is, -1, 2. Okay. We also found these other points, 0, 3, -2, 3. Okay, that's what we found. And then what was my last point there was that at -3, that would be here, the value was 9, or the value was 6, okay? There, so the value is 6. So that purple line there is really representing the sum of these other three functions. Okay, let me take it out. Let me turn it off, I mean. See? So we started from this line here, we started from nothing, we added in y equals 3, then we added in y equals 2x and y equals x squared, and then we've got the composition of all those, y equals x squared plus 2x plus 3. Let me turn them all off, and there's that's that addition of all those different little functions together. So we can now think about quadratic equations visually as the sum of all of their parts, you know? So that is kind of a cool thing that that I think is really neat. I think that's really cool. I hope that you found this interesting. You know, I think it's a really interesting way to look at graphing a function by breaking it down into pieces and then adding up the y values where they all are passing through a specific x coordinate. So really cool. I hope that you found that to be both educational and entertaining. Thanks.